When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. In this video we're going to cover one of the past HSC exam questions of the Theory of Acids and Bases chapter. While I'll do in a second, I'll read the actual question. Once I read the question, you have about 5 seconds to pause the video. Once you pause the video, attempt the question, and then press play when you're ready. The question itself is: analyze how knowledge of the composition and properties of acids has led to changes in the definition of acids. And that's worth 5 marks. So when you're ready, pause the video and attempt the question. Welcome back. Alright, this question's worth 5 marks, and you're obviously meant to be analyzing the change in the definition over time, and it says specifically about the acid, so you don't have to talk too much about the bases. So if you remember, there's a couple of videos, I think one video where we talked about that. We talked about 5 people which are important. First was Robert Boyle, and he just came up with the observations that acids were sour. Then came Lavoisier. Then came Humphrey Davy. Then came Arrhenius. And last but not least, there was the Bronstein and Lowry theory of acids. And that's what you have to do. It's worth 5 marks, and you can see there's 5 people you should really mention in that definition to cover, or 5 theories to cover all of it. So what do you mention? You mentioned the actual person and what his theory was, and how that helped disprove the previous theory. So what his theory was, and how that disproved the previous one. So you usually always build up on the previous one and somehow manage to disprove it. So what I wrote first was, the earliest definition of acids were based on observations made by Robert Boyle in the 17th century. And he defined acids as sour tasting, having corrosive properties, and also changed the color of vegetable dye. Right, so his were just the observations made, the earliest sort of rough definition of acids were these observations made by Robert Boyle. Then I wrote about Lavoisier and what he came up with. In 1779, Lavoisier noticed that many oxides and nonmetals were acidic in nature. So that was observation, which led to his theory of oxygen causing acidity. So he had the oxygen theory of acids. This was later shown to be incorrect. So this is why it was then proven incorrect. So it was later shown to be incorrect, as metallic oxides that also contained oxygen were basic. Right, so we talked about theory here, and then we talked about why it was incorrect. And then that leads into the next person. So that was Davy, came after Lavoisier. Davy conducted an experiment with hydrogen chloride to produce hydrochloric acid. So that was his experiment. He had hydrogen chloride, put that in water, and produced hydrochloric acid. This experiment showed that hydrochloric acid, containing no oxygen, so the actual hydrochloric acid had no oxygen in it, but was still acidic, and thereby disproving Lavoisier's theory. So that was one of the evidences to show that oxygen itself was not important when it comes to acidic behavior, because you could have hydrochloric acid which had no oxygen, but still produce a acidic solution. Davy's theory, later slightly modified by German scientists, linked the acidic nature of substances with replaceable hydrogens in their chemical structure. So this was the actual theory. His theory was the replaceable hydrogen theory of acids. And obviously that was disproven later, and that's what I'm going to talk about now. Later experiments showed that some metals, when reacted with acids, produced nitrogen dioxide and not hydrogen gas, and thereby disproving Davy's theory. So his theory was all about hydrogen gas being the thing that causes something to be acidic, but we had that acid being combined with a different metal which produced nitrogen dioxide and not hydrogen gas. So that disproved Davy's theory. So then later the next person came up with this new definition, that was Arrhenius. Came up with a new definition in 1884. It's actually probably good to remember those rough dates as well. That linked the acidic nature of acids with the likelihood of producing hydrogen ions in solution. So here we got the hydrogen ion theory of acids. This also helped explain the existence of strong and weak acids. That was new for his definition, as it could be linked to the degree of ionization of the acid itself. So now we've gone from the earliest observations to Arrhenius' theory. We've covered 4 people, which means 4 marks so far. So 1 for Robert Boyle, 1 for Lavoisier, one for Davy, one for Arrhenius, and then last but not least Bronstein as well. In 1929, Bronstein and Lowry, working independently from each other, came up with a new theory of acids and bases. So this is his new theory, and then I'm going to talk about why the old theory broke down. And this is this part. The previous theory could not account for why some carbonates would produce acidic or basic solutions, but released no hydrogen or hydroxide ions into the solution. So this is why even there were no ions in solution, but it was still acidic or basic, thereby disproving that it has to be the hydrogen ions or the hydroxide ions which cause them to be basic or acidic. That was what was disproved Arrhenius' theory, and then obviously Bronstein and Lowry came up with a new one. Bronstein and Lowry theory described acids as proton acceptors and bases as proton donors. Again, the question doesn't ask about bases, but I'll just put that in there. And this theory still is accepted today as the current theory. Let's see that it's a mark as well. So now we've got 5 marks out of 5. We've gone through all of the different sort of advances and linked them to the properties of acids and the composition. So that's explaining why these actual advances came about and why they were then disproven as well. And the actual dot point was 2 more or less. So outline historical developments of ideas about acids, including those of Lavoisier, Davy, and Arrhenius. Note that it says including, so it doesn't say that you have to only know these 3, it says including. And the other one was gathering plus information from secondary sources to trace developments in the understanding and describing of acid-base reactions. And those are mainly this one, and a bit of this one, but overall you should just know these 5 individuals and the sequence of their discoveries and how that eventually led to Bronstein and Lowry's current theory. But yeah, hopefully that was useful.
Thank you for watching.